Consider the internet. It's everywhere, right? Floating through the air, delivered to our phones, our computers, our game consoles. Most of us get that internet from a little box called a Wi-Fi router. Wi-Fi uses invisible radio waves to send information, kind of like a tiny super-fast radio station in your house. It's pretty amazing. But what if I told you there's another way to get online? A way that uses something we see every single day. I'm talking about light. The very same light coming from the lamp on your desk could bring you the latest cat videos and science articles. This technology has a very cool name, Li-Fi. Li-Fi stands for Light Fidelity, and it's a lot like Wi-Fi, which stands for wireless fidelity. They're both wireless, meaning no pesky cables are needed to connect you to the vast world of the internet. The big, huge difference is what they use to carry the data. Wi-Fi uses radio waves, which are part of the electromagnetic spectrum. Li-Fi, on the other hand, uses visible light, the same stuff that lets you see the world around you. If Wi-Fi is like hearing the internet, then Li-Fi is like seeing the internet. The flicker you can't see. Okay, so using a light bulb for internet sounds cool, but how does it actually work? Are there tiny bits of data physically riding on the light beams? Well, not exactly. The secret is all about turning the light on and off, really fast. The technology uses a standard LED bulb, but one that has a special microchip installed. This chip allows the bulb to flicker at speeds so high that the human eye can't possibly detect it. To you and me, the light just looks like it's on, steady and constant. But to a special detector, that flickering is a language. It's a code. It's a code based on a simple binary system. Think of it like a super fast game of Morse code. When the LED is on, it can represent a 1. When it's off, it can represent a 0. By flashing on and off millions or even billions of times per second, the LED bulb sends a stream of 1s and 0s. A special device on your laptop or phone, called a photodetector, sees this incredibly fast flickering. It reads the pattern of 1s and 0s and translates it back into the data you understand. When we talk about new technology, one of the first questions is always, is it better than what we have now? When it comes to speed, the answer for Li-Fi is a resounding yes. While your home Wi-Fi might give you speeds of a few hundred megabits per second, Li-Fi has been tested in laboratory settings at speeds of up to 100 gigabits per second. That's over 100 times faster than the fastest commercially available Wi-Fi today. To put that in perspective, at that speed, you could download multiple high-definition, full-length movies in a single second. It's an almost unimaginable amount of data, delivered in the blink of an eye. Another amazing advantage, or superpower, of Li-Fi is its security. Wi-Fi signals, being radio waves, travel through walls, floors, ceilings. That's convenient, but it also means your network signal can spill outside your home where it could potentially be intercepted by someone with malicious intent. Light, on the other hand, does not pass through solid objects. If you are in a room with the door closed and the blinds drawn, the Li-Fi signal is contained entirely within that room. No one can eavesdrop on your data from the hallway or the apartment next door. This makes Li-Fi an incredibly secure option for businesses, governments, anyone concerned about digital privacy. Now, as with any technology, Li-Fi isn't perfect. It has some limitations that are important to understand. The biggest and most obvious one is its reliance on a direct line of sight. Think about it. If you can't see the light, you can't get the data. This means that Li-Fi signals cannot travel through walls, doors, thick curtains. If you walk from your Li-Fi living room into the kitchen, your connection will drop. That same containment that makes Li-Fi secure also limits its range and mobility compared to Wi-Fi. This line-of-sight rule changes how we move around homes and offices. With Wi-Fi, one router can bathe an apartment in radio waves. With Li-Fi, you need a Li-Fi bulb in every room. Your device must hand off between lights as you move. Technically possible, but it needs a more complex, widespread infrastructure than one Wi-Fi router. Another limitation: the light needs to be on for internet. Some systems work when lights are dimmed almost off, but they must still be powered. Fine for daytime or always lit offices, but at night when you want to sleep, you may have to choose between internet and total darkness. So, what does the future hold for Li-Fi? Is it going to replace Wi-Fi and become the new standard for wireless internet? Probably not, at least not completely. Instead of thinking of it as a replacement, it's better to think of it as a powerful partner. The future of wireless communication is likely to be a hybrid system. Imagine your phone automatically using a super-fast, ultra-secure Li-Fi connection when you're sitting at your desk, and then seamlessly switching over to Wi-Fi when you put it in your pocket and walk to another room. Smart cities. streetlights providing public internet to pedestrians, traffic lights talking to self-driving cars, sharing real-time traffic and road condition data to reduce accidents and congestion. In a crowded stadium, overhead lights giving thousands of fans high-speed connections for instant replays. Connectivity woven into the fabric of our environment, delivered safely and efficiently through the light around us. Li-Fi is still a relatively young technology. It needs standardization and mass production to go mainstream. You can't yet buy a Li-Fi-enabled laptop or a Li-Fi light bulb. In conclusion, Li-Fi is one of the most promising communication technologies on the horizon. Li-Fi isn't just a bright idea. It could genuinely illuminate our world. The future of wireless is, quite literally, looking bright.